Welcome back, guys. We are continuing with those two trying owns that we ended with on our last video, these two problems. So I'm going to walk you through both of them. The first one is very similar to the example that I did in the first video. Second one, though, gets a little bit tricky, and there's a very common mistake that students make every year, so I want to make sure that I really talk about that second one. Let's get started on the first one, though. So on this problem, the first step is to factor our denominators. So anytime that you see adding or subtracting in the denominator, you need to factor first. Both of these have a GCF. My first one has a GCF of 2h. And my second one has a GCF of just 2. Now I'm also right now going to push this minus sign up to the top just to make sure that I don't make a mistake later. Next, I'm going to create a common denominator. Now, these two denominators are almost identical. They have exactly the same parentheses. They have that in common. They also have an outside number 2 in common. The one thing that the first one has that the second one is missing is the first one also has an outside h. So we need the second fraction to have an outside h, an h that's not trapped in a parentheses. So I'm going to multiply by just the letter h. Okay, I did not change the first fraction at all. First fraction was fine. I multiplied the second fraction by an outside h. At this point in time, since I've created my common denominator, I'm ready to write my restrictions. So from the denominator, the outside h, the 2h, that's going to be a restriction of 0. And then the parentheses is going to give me a restriction of the number 1. So my two restrictions are h cannot equal 0 or 1. Next, I'm going to smush my fractions into a single fraction. That single fraction will have the common denominator, the 2h and the h minus 1. And then we just make a long adding problem. So 3 plus negative 5h. Next, I should try to factor my numerator, but my numerator does not factor. And since the numerator is not identical to anything in the denominator, I'm going to go ahead and say that I'm done with this problem. So remember, those last two steps do not always happen. We cannot factor the numerator in this question, and we cannot cancel anything. And that's okay. This is my final answer for that problem. Hope you did well. All right, but let's talk about that second problem, because that second problem is really tricky. Just like the first problem, I'm going to start by factoring my denominator. Now, only the first denominator can actually be factored. That's an Xbox problem. I get x minus 5 and x plus 1. My second denominator cannot be factored, but it is an adding problem. And so anytime you see adding or subtracting, you want to throw some parentheses around it so that it's grouped together. Comparing my two denominators, they both contain an x plus 1. They already have that in common. But my first denominator has an extra parentheses, which is x minus 5. And so I should multiply my second fraction by x minus 5 so that they have the same denominator. Again, I'm not going to change my first fraction. First fraction was fine. For my second fraction, at this point in time, I need to take my 1 and distribute it. And when I distribute it, the parentheses will go away. And that's a good thing. We do not want parentheses in the numerator at this point in time. Maybe in like 2 or 3 steps, we'll get some parentheses in there. But right now, parentheses in the numerator are bad. And if you put parentheses in the numerator, I'm going to guess you probably made the mistake that I've seen every year on this problem. And we'll talk about that in a second. Now that I've created my common denominator, I can go ahead and write my restrictions. Since there are 2 parentheses in my denominator, I should get 2 restrictions. One of them is positive 5, the other one is negative 1. So x cannot equal positive 5 and x cannot equal negative 1. Also, now that I have my common denominator, I can smush my fractions into a single fraction with the common denominator. And then for your numerator, you're creating a very long adding problem. Again, no parentheses, no multiplying, adding or subtracting. So you're going to do 6 plus x minus 5. 6 plus x minus 5. And again, at this point in time, there should be no parentheses. Parentheses would be bad. If you have parentheses, you probably canceled right now, and you cannot cancel right now. So just leave it a really long adding and subtracting problem. The next thing we're going to do is we're going to combine like terms. So I have a constant, the number 6, and I have a constant, the number -5. So I'm going to combine those together. 6 minus 5 is 1. Now that I've combined like terms, and I've created, as simple of a numerator as I can, it's an adding problem. It doesn't factor, but I can throw parentheses around the entire adding problem. Okay, around the entire adding problem. And since the entire adding problem is exactly the same as this parentheses, I am going to be able to cancel those at this point in time. The correct answer for this problem is 1 over x minus 5. Now, here's the mistake I see students make every year. They leave the x minus 5 in parentheses right here, and then they try to cancel the x minus 5s. And you're not allowed to do that. We don't want parentheses to be around a portion of an adding or subtracting problem. If I was going to write parentheses around the adding and subtracting, I would need it to be around the entire thing. So I could put parentheses to all the way out here, but then again, you can't cancel out a portion of a parentheses. It's all or nothing. And so that's the mistake I see a lot of students make. So just try to be aware, you don't want parentheses. Actually, on this step right here, all of your parentheses in your numerator should be gone. No more parentheses in the numerator. And then don't forget on this next step that you have to combine like terms. Okay, so those are the two big things to kind of look for. Parentheses are actually really bad in the numerator. They're great in the denominator, but not in the numerator. So just be aware of that. This concludes today's videos.